Yeah. Hi, everyone. So let's get started. Hello, Shivam. Hi, Shivam Bharti. Okay. So today we are going to discuss the practice set that I have uploaded on the asymptotic notations. Have you tried those questions? Okay. I hope you have tried, right? Cool. So let's start from the question number one. But before that, let me quickly remind you that these are the few things that we have already discussed, which means like what are the big O notations and all of this, right? Okay. So a big omega notations and these things. So if I'm saying big O notation, which means if I'm saying Tn is a big O of Gn, then it means Tn is less than equal to Gn, right? For some C and after some N naught. So basically after some N naught, it is less than equal to, and C must be greater than 0, right? That's what we have said. Okay. Similarly, I mean, the C is actually greater than 0. Similarly, that is true for big omega. Similarly, that is true for theta. Okay. And there is one toolbox that we have discussed that if you are taking log, then you have to be careful, which means if after taking the log, if the function, if the logarithmic function are asymptotically greater, then you are saying the real functions are greater, right? If after taking the log, if absent, this is lesser, then the real functions are lesser. But if these are equal, then we can't say anything. Okay. What is the significance of C in the graph of big O? Significance of C means, I mean, it is basically just a constant. It is saying that there is some constant which doesn't matter, which means this function and this function are differing by a constant. I mean, if you can adjust the constant in your own way, which means whatever constant you can just ignore the constant, or in other words, that you can adjust the constant in your own way, such that after a point in time, this Tn is strictly lesser than equal to this Gn function. And whatever is the constant, maybe this constant could be fraction also. You can adjust the constant in your own way. I mean, this constant is basically just it is just saying that yeah, it has to be a real number. Obviously, like if it is a real function, then it has to be a real number. There is no point in complex number. I mean, we are in the real world. Complex things, we talk about the complex things when there is no control on the real things. I mean, we cannot talk about the real things, then we talk about the complex things. Okay. So it is saying that these are the two functions. Let's take two functions. So let's suppose this is function number one, and there is another function, whatever the function you are taking. But after a certain point in time, okay, after a certain point in time, this function is always greater. Let's suppose this function is always greater. Now you can adjust the constant little bit. Constants does not matter. This is what it is saying. Okay, I mean, you can divide this function by the constant. You can multiply this function by the constant, or whatever you want to do, you can do it. Okay, this point is called turning point, right? Okay. So after a certain point in time, this function is greater. Now, what about the constant? Constant means like you just ignore the constant, which means like I mean, you can adjust the constant in your own way. You can multiply or divide by any constant with this function. It should not matter. Okay. I mean, there is a pair of C and not that must exist. Okay. Have you understood this particular slide? Because this was extremely important. That after the log, if both are equal, then we can't say. This is very important, right? Okay. So I'm like in this particular practice set, I'm saying that all functions that we have used are positive and increasing, which means that they always gives a positive result, which means there is no negative function, which means f of x or f of n is always greater than 0. And these are the increasing functions. Okay. Yes, we have to cancel the common terms in case of this log. I mean, it is better like if both are coming equal, then most probably you might not have canceled the common terms. Okay, most probably. Cool. Let's take this first question, which is from Stanford. But the question is, I think, very easy. They are saying that n square log n. So n square log n is, I think, if you are saying order of n, it means that order of this. I mean, if Tn is order of n, it means what? My voice is clear, or there is some lag today also? Just want to confirm it. Okay. If there is lag or something, you can let me know. Okay. Cool. So is this true that Tn is less than order of n? I mean, Tn is less than n. Is this true? I don't think, right? So that's why this is not true. This is also not true. This is also not true. Tn is definitely greater. So this is definitely, in fact, it is strictly greater, right? So that's why D is true and this is not true. So I think only D is true. So I hope that is easy for all of you. So I think D is the correct answer, right? Now let's say what it is saying, that Fn is order of n if there exists some value c comma n naught greater than 0 such that Fn is less than or equal to cgn for all n greater than or equal to n naught. I mean, they are just rewriting the definition of this big O. That is fine. Now they are saying which of the following is true about this definition. Select all that apply. C and n naught cannot have the same value. No, there is no relation between C and n naught, right? So there is no relation between C and N naught. I mean, they can take same value or I mean, these are independent basically, right? So can take same value. Must be integers? No, that's not true. I mean, after a certain point in time, it should be greater than. I mean, one function should be greater than another function. It need not to be that turning point need not to be integer. Neither the constant should be integer. So in fact, the constant, as I told you, it could be fraction also. I think we might have done some question where the constant was fraction. As far as I remember. So in the class, do you remember that we might have taken some example where the C is fraction? Yeah, C is 1/2 or something, right? Cool. So if Fn equal to Gn, then if both are equal, then yes, then you can even apply theta. Then what's an issue, right? So C is true. Gn cannot be order of one. Gn cannot be constant function. No, Gn can be constant function. I mean, Fn is order of Gn. So, I mean, here this Gn can be any function. So, can be constant function. So, that's why only C is the correct answer. Okay. Have you understood why C is the correct answer? Can we say positive numbers? Please write your statement clearly, which means, I mean, in which option, which positive numbers? Yeah, I mean, C and N naught you're talking about, they must be positive, yes, as per the definition. Okay. I think n naught even can be 0, but yeah, in this definition that they have given, that n naught they have taken it greater than 0, does not matter much. Okay, cool. Now let's see this. So they are saying that C is greater than 1. I mean, C is some constant which is not fraction, which is greater than 1. Okay, strictly greater than 1. Then 2 power tn. 2 power tn means 2 power n power C. Okay, just tell me, if I'm saying 2 power n power C, can I write it like 2 power n power C? Is this true? No, right? See, this is n power C. Have I talked about this in the lecture? I don't exactly remember about this particular thing, right? I must have talked about. Okay, so this is 2 power n power C. This is not 2 power n power C. I mean, these are. I mean, if you do this, then it is basically 2 power n C, right? So this is not. These two are not equal actually. Okay, so 2 power n power C is basically same as saying 2 power n. I mean, 2 power basically n power C. I mean, you are doing this power first. Okay, you are doing this power first. This is correct. This is correct. And if I say this is wrong. Okay, so this is wrong. This is correct. And what does this 2 power? What does this 2 power n and then whole power C? It means, so basically, if I just say 2 power n whole power C, it means 2 power n into 2 power n into 2 power n. I mean, see, power C means C times, right? C times. So into 2 power n, C times, which means you just add all of this n, which means 2 power Cn or 2 power nc. Okay, cool. So this 2 power n power C, they are saying which one is equal. So you want to compare this 2 power n power C where C is strictly greater than 1. Okay, and then 2 power n. What do you think? Can I write order? I mean, I can compare. I can definitely compare. Let me probably compare it. So I want to compare 2 power. Just a second. Let me write it here. So I want to compare 2 power n power C and 2 power n. versus, right? Let me write versus. So which one is greater? You can take log, and after taking log, you will find that this is strictly greater, right? So since this is strictly greater after taking log, so you can do this. So you will say that log of 2 power n power c, and then log of 2 power n. Here you will say this will be just n power c. This is n. So which is greater? This is strictly greater. So that's why this is strictly greater, right? So you will say 2 power n power c is equal to order of, sorry, 2 power n is equal to order of 2 power n power c, right? So can you write this in the order? Can you say this is correct? See, this is 2 power n power c. Can you say this is lesser than equal to 2 power n? I don't think, right? Where c is strictly greater than 1. So in fact, this is greater than equal to, right? See, after, let me just go over that slide. You take log. If after taking log strictly greater, then strictly greater. Okay. If after taking log you get equal, then you can't say. If it is strictly greater, then strictly greater only. If it is lesser, then it is lesser. If it is equal, then you can't say. Okay. And all comparisons are asymptotic. All comparisons here are the asymptotic. This is the asymptotic comparison. This is the asymptotic comparison. All comparisons I'm talking asymptotically. So here after taking log, you have found out that this is strictly greater, right? So since this is strictly greater, so you will say this is greater. So you cannot write like this. So this is saying that 2 power n power c is strictly greater, right? It is saying, sorry, it is saying it is greater than equal to 2 power n. Is this correct? Yes, this is true. This is saying, c is saying that 2 power 2 into tn is n power c is same as 2 power n power c. What do you think? Are they same? Are you sure about it? This is not plus, okay? This is not 2 power 2 plus 2 power, no, 2 power 2 plus n power c. This is not 2 power 2 into 2 power n power c. This is not 4. This is not constant. Just divide by 2 power nc. Just divide this number. Okay. So just divide this number 2 power n power c by both sides. This will be 2 power n power c. This will be just 1, isn't it? So these are not equal. In fact, this is strictly greater. So these are not equal. Is this okay to everyone? Let me know. Okay. I hope that is right? So that's why this is false. Now, what about this? This is saying that 2 power n power c equal to, this means what? 2 power n power c is greater than equal to 2 power 100 n into c. What do you think? Can you take log and compare these two functions? So I want to compare these two functions. So just take log and compare, right? Okay. So what is the answer you are getting? This is n power c. This is 100 nc. 100 you can definitely ignore, right? After taking log. So log, I have taken log, right? Now, which one is greater? This 100, this is just n. This is n power c, where c is strictly greater than 1. So obviously this is strictly greater. So this n power c, 2 power n power c is strictly greater. Since 2 power n power c is strictly greater and it is saying greater than equal to, yeah, that is fine. So I think D is correct, right? Is this okay to everyone? D is correct. Okay, just take log and compare these two functions, if this relationship hold or not. Okay. Okay. Now let's check these functions. I think this is n square. You can definitely write n cube. This is n square, n square, n square. No, theta is not correct. N square, n. Yeah, this is correct, right? Is this okay? that n square is, this is saying that n cube is less than equal to, it is saying less than equal to, it is saying equal, and it is saying greater than equal to. So I think this greater than equal to is correct. I mean, equal are not correct because this is n cube. And all comparisons are asymptotic, which means I am ignoring the ignoring the constant and all of this story, right? Okay. See, this particular topic is actually very easy. That's why I have taken the multiple examples so that you get to, familiarize with these topics, this particular notation and all, because that's what you will be requiring again and again. And not actually, this particular subject, the data structures and algorithm, is not just important for gate. I mean, obviously we are preparing for gate, so it is very important for gate. I'm not denying this fact, but it is actually very, very important for your placements also. I mean, later on, even after 10 years, it will be very useful. Let me tell you one story, that I was taking one interview or when I was at Amazon. So Amazon gives you a chance to take the interviews also. Okay. So I was taking one interview, and this so happened that I was taking one interview of some fresher. And like I asked these notations and all. Okay. I mean, there was some notation, this asymptotic notation I asked, and he was not very much confident about it. So that gave me, to be honest, that gave me not very positive impression about that particular interview. Okay. The reason was very simple, because I was expecting these notations to be very much crystal clear, and he was not able to answer some tricky questions on the notation. So the impact doesn't go very positive in that sense. Okay. Like, I was not asking very tough questions. Maybe I don't remember the exact question, but maybe I was asking just normal questions about this asymptotic notations. Okay. So were you able to solve this question? Ajay is saying L5 interview. No, L5. I cannot take L5 interview. I was L4 only. So I was taking L4 interview only. Okay. Find the order of growth for the following sum. So I think that is easy. So I'm just skipping this. You can just see the solution. That's very easy question, right? Okay. By the way, can you tell me, if I just ask you maybe something like this, order of this, instead of I, let me use K. K seems good. So suppose if I just ask you, can you find out this summation? Can anyone tell me how to do this? This summation? Have you seen these kind of things before? Yes, this is AGP. So you can try this as an homework. Actually, there is one of the question in the next practice set, which is stack and queue practice set. So in that stack and queue practice set, there was one of the question which in like you have to do that question using this summation. Okay. So I mean, you will be encountering this kind of summation in stack and queue practice set. Anyway, so let's move further. Now, for which of the following following five functions, you need to basically group them, right? I mean, you need to tell the order. Okay. Okay. Was this confusing? Let me just take it. So let's just check the order of this. So one thing, right? I mean, 2 power n is greater than n power anything. I mean, you can even check with the log, right? This is basically n. This is log n, and n is strictly greater than log n. So 2 power n is strictly greater than n power anything, and similarly in the same way you can say that log n power anything. I mean, n is greater than log n power anything. So do you remember these things? And n power even epsilon. I mean, n power even very less power is greater than log n power even very high power, right? Okay, good. So now this is 2 power. I think this f4 is greatest, right? I don't think there is any confusion here. Now, among this, all of this, I think this is n cube. Everyone is lesser than n cube to me. So can I write f3, or there is any confusion after f4? I'm 100% sure there will be f3. I mean, this n cube is greatest, right? I mean, n square log n whatever, right? It cannot be greater. So that's the story. Now I think f4 and f3 are done. Now let's talk about this n square log n. This is just 2019. You can take it outside, doesn't matter. So this is n square log n. this is log n something, this is n log n. So definitely this f2 is greater. And then this is log n power anything. This is just n, right? I mean, this n is very, very greater, I think. So f4, 5. And then f1. 4, 3, 2, 5, 1. Okay. So this is the answer that we are getting. Let me just check. Okay, I mean, they have written it in the increasing order. I have written in the decreasing order. Doesn't matter. So 1, 5, 2, 3, 4. You can say, right? 1, 5, 2, 3, 4. I mean, in whatever order you want to write. Okay. So I hope that is okay. Now let me take this particular question. So by the way, this question we have taken from MIT, right? Now, what I'm thinking that, we can do two things. Like I'm little in confusion about it. That either we can, discuss only practice set first, and then once all of this data structure is done, which I'm planning in 4 to 5 days, once all of this data structure is done, then after that, or I mean 6 to at max 7 days, I'm planning for the data structure. After that, we can do data structures P by Q, or we should be doing data structure P by Q along with that. I'm thinking that we can do practice sets first, or then we can take one marathon just immediately after this. This is done. Okay. Okay, we will be taking immediately after the data structures course is done, right? And some PYQs are very, very interesting that I definitely want to talk about. Now let's talk about this. So this is n factorial upon n. NCR is n factorial upon r factorial into n minus r factorial, right? So this is n minus 2, sorry, n divided by 2 factorial into n divided by 2 factorial. This is just n factorial. This is n factorial upon 3 factorial into n minus 3 factorial. Or you can just say, I think, n into n minus 1 into n minus 2. This is just n cube, right? This is just n cube. Okay, I think f2 and f5 are equal. So can I just write this as just n cube? Is this okay that f5 is n cube? Is this okay to everyone? I mean, asymptotically, right? So f2 and f5 are equal. Let's talk about these things. 2 power n. So which one you think? Let's talk about f1 and f4. Which one you think is greater? 2 power n and 2 power n or n factorial? 2 power n. Okay. Why? Can you compare 2 power n and n factorial? Let me just do it. This is after taking log. This is n. And this is n log n. Right? So I think n factorial is greater. Strictly greater. So n factorial is greater, right? Why you guys are saying that this is greater? 2 power n. So I think n factorial is greater. And then 2 power n. So basically, n factorial is greater. See, the only confusion is between, and like these are the n cube. These are the n cube. That is okay. The confusion is between, I think, these things, right? So let me do one thing. Let me just take it on the next page and let me just see one by one what is happening, right? So basically, here I can say that this is n cube. So I will keep it later. Okay. Let me just remove this for now. I mean, remove in the sense like I will just focus on them after a minute. Okay. I mean, let me just remove this. Okay. Okay. Let's just talk about this n factorial, and this is n factorial upon n by 2 factorial square. Right? Let's just talk about these two functions. So if you compare between n factorial and n factorial by n by 2 factorial square, right? Then which one is greater? This is f3. Sorry, this is f4. This is f3. You can do one thing. You can multiply by n by 2 factorial square both side and divide by n factorial both side, right? So if you multiply this n by 2 factorial square both side and divide by n factorial both side, so it will be just 1, right? It will be n by 2 factorial square. So I think it is strictly greater. So F4 is strictly greater. So this n factorial is actually strictly greater than F3 and F1. So can I say that F4 is very, very greater? I mean, it is actually greater than this F3 and F1. Can I say? Now, one thing is for sure that this F4 is greater. Now I want to talk about this F1 and F3. Now let's just see that which one is greater, right? Okay. So F1 and F3. So what do you think? This F1 is 2 power n. F3 is greater. Which one is greater? Binomial coefficient term? I'm not getting. Am I mistaken something? Binomial coefficients are for, I think, x plus y power n, right? I mean, here, what is the concept of binomial coefficients? Okay. So F1 seems to be greater. How you solved it? NCR is 2 power n? No, it's not true. Okay. So what you can do, maybe, should I take log, or maybe before taking log, I can just multiply. I can just multiply with this. Okay, sigma NCR. Yes, that is true. Yeah. Sigma NCR from 1 to n, right? Okay. Let me just multiply this n by 2 factorial square both side. This is 2 power n into n by 2 factorial square. This is n factorial, right? Now just take the log. If you take the log now, this is n log n. This is n plus log of n by 2 factorial square. You take this 2 outside, and then it will be n by 2 log n by 2. So this is n plus n by 2 log n by 2, which is again n log n. I mean, if you just simplify this is n log n. So this is n log n, this is n log n. Both are coming out to be equal. So what to do now? Okay. Didn't get this calculation. See, what I'm doing. Have you understood that after multiplication, this is, I mean, if you multiply this, then this is coming out to be right. Then if you take log, this will be log. I mean, n will be outside. This is log 2, which is 1. Plus, if you take log of this, it will be the term, right? And you take this 2 outside, then this is log n by 2 factorial. Log n factorial is n log n, right? This is n log n. This is n by 2 log n by 2. I mean, instead of n, you have n by 2. Okay. So instead of n, you have n by 2. So it is n by 2 log n by 2. So after taking log, both are coming out to be equal. Actually, this is little complicated, I think. Okay. So what are the other way in which we can compare these two functions? No, we always talk about asymptotic. This is the asymptotic comparison. We never care about these things, right? I mean, if you care about these things, then let me just take 3 here. I mean, you ignore the constant, but I can just write 3 here, which means n log n plus n log n plus n log n 5 times, right? No, that is okay, but concept should be, I mean, clear at the practice time only. Okay. So now let me move to the next page, and let's just think some other way to compare between these two functions. So log is not working, right? So what can be some other way? That's what I'm thinking. Let me check how they have compared. Okay, this order follows from the definition of binomial coefficient and the string approximation. The trickiest one is f3 equal to f3. They have written 2 power n upon. Okay. Do you remember that approximation that we talked about? What is this? I think this into. Can anyone write it? Exact approximation. I don't remember the formula. Yeah, I think for this complicated one, we have to remember. I don't think there is any other way I can think of this as of now. So for this one, we have to know the formula for the n factorial. Can anyone tell me the formula here? N upon E, something like that, right? How would I know? Like these kind of questions, please don't ask me that will this will be asking it. How would I know that will this be asking the gate or not? So if you know this, then you can do it. Otherwise, you can definitely skip this, right? Okay. Yeah, I think that's the one, right? So this is n factorial. Now, if you do n by 2 factorial square, so can I just skip this? Actually, I don't think it is even required. So if you want, I can just skip it. Otherwise, I can do it. Okay. So if you take this square, then let me just cancel this. So this is 1 by 2. This will get cancelled out. This will be just n, right? Okay. So here, these are just constant. So this is square root of n. This is n. So finally, you will be getting square root of n. I mean, here you are getting square root of n. And here, this is n power n, which will get cancelled out. This is e power n. So this is n power n upon e power n. This is 2 power n into e power n upon n power n. So this is 2 power n multiplication. Okay. 2 power n upon square root of n. Okay. So it is coming out to be 2 power n upon square root of n. So that's why this is strictly greater, right? Because this is divided by some function. So that's why this is strictly greater. So F1 is strictly greater. Okay. So if you know this approximation, I mean, if you remember it, it is okay. Otherwise, you can skip these kind of questions. That is fine. Okay. I don't think there is any other way to solve this other than knowing this approximation. And also this approximation, remembering this approximation is also not a great deal. I mean, I almost remember it, right? I have written till this point. I was just in the confusion whether I have written till this point. I was just in confusion whether there is something else or directly power n. Can we think in terms of sum of binomial coefficient? This way 2 power n will be greater than f3. Okay. Can you tell me that formula? 2 power n is NC0, I think. Is this correct? Okay. Can you confirm if this is correct? Now what you're saying? This n factorial upon n by 2 factorial square, and this now you can compare. That's what you're saying, right? Okay. So yeah, this is NC0, which is n factorial plus, I mean, there will be some plus terms, right? NC1 and these things. Okay, I'm not sure that how you are going to compare now. If even if you break, this is NC1 plus NC2. Okay, so this NC2 is n factorial upon. I mean, since these are the plus terms, right? These are the plus terms. So So that's why I don't know if there is any direct way. Okay. Anyway, let's leave it. That's not required for us. Okay, someone is saying we can always take the significant term out. No, that's not always true. It's not like that you can always take the significant term. I mean, you can take the significant term, but number of the terms should be the constant. Just everyone, just listen this very carefully, because this might be a common misconception. I mean, you might be thinking that you can take the. I mean, if you sum this out, you can take this n factorial directly. Are you thinking like this? I mean, because all of these terms are n factorial divided by something or something. Anyone thinking like this, then that this summation is just n factorial asymptotically? Let me know. Anyone? Or if you are not thinking like this, then tell me what is the flaw in this. Why we can't write this as n factorial, this whole summation as n factorial? Because every other term is less than n factorial. Then why we can't write like this? If you are thinking, then it is wrong. If you are not thinking, I mean, then why you are not thinking, basically? You got my point? Have you understood my question, what I'm saying? This n factorial plus n factorial divided by something plus n factorial divided by something is definitely, I mean, the significant term is definitely n factorial. Then why I can't write n factorial directly? Anyone? No, it's not about significantly lesser or no. What do you mean by significantly lesser? It is not like this. See, suppose you write log n plus log n plus log n, let's suppose n times plus log n. Okay. The number of terms are n here. Can you write the significant term log n only? Can you say it is just log n? Or this is n log n? Let me know. This is definitely n log n, right? If number of terms are itself a function of n, right? If the number of terms are itself in the is some function, then you can't take the significant term. The significant and all are okay as long as you are having the limited, I mean 2, 3, 5, 10, 100, 200. But if it is n terms, right? These are the n terms here. These are the n terms. You can't take the significant term. Okay. These are the n terms here. Okay. The total summation is of n terms. You can't take the significant term in these cases. If the number of terms itself are the n or in any function of n, you can't take the significant term. Okay. Is this understood to everyone? That why we can't write n factorial? Because the number of terms itself are a function of n. Okay. See the example that I just told you here, the number of terms are itself is a function of n terms, or maybe square root of n terms or whatever, right? I mean, any fn terms, any function of n, then you can't write the significant term. It is only applicable for the constant number of terms. The constant could be anything again. Okay. Can the constant be 10,000? I mean, if these are the 10,000 terms, can I write log n? Yes. If these are the 1 lakh term, 10 lakh, 1 crore or 10 crore or whatever, right? Then I can write log n. I mean, as long as this is constant, these are the constant number of terms. But if it is just n terms, then you can't write. I mean, any function of n. Okay. Cool. Okay. Now I think that was done. So here it is coming out to be that 2 power n is strictly greater, right? So anyway, now 2 power n is strictly greater. So what is the answer? Now n factorial and 2 power n, which one was greater between n factorial and 2 power n? N factorial was greater. Okay. So here, let me write the final answer. Yeah. So here, n factorial was strictly greater, right? Then 2 power n, and it is greater than 2 power n by square root of n, right? 2 power n by square root of n, which means, I mean, this is basically f3. Okay. This is f3. And then, which is greater than, I think this is done, this is done, then n cube. Okay. Now you write f2 or f5, doesn't matter. So f2 comma f5. Okay. Cool. Now let's see this question. So which of the following statement, which statement on the growth of the constant function is true? Okay. So can you write 100 equal to order of 0? Let me know the definition of order of n. Fn equal to order of Gn. What does this mean? That Fn is strictly, less than equal to C into Gn for some C greater than 0 and for some n naught, right? For some n naught. This is the definition of Fn. So can you write 100 less than equal to C into 0 for some C? Can 100, see, first of all, tell me, is this the asymptotic comparison? Tell me, is this the asymptotic comparison or normal comparison? This comparison that I'm writing, is this asymptotic? Normal, right? When is the asymptotic comparison? I mean, like, okay, suppose I'm writing this. Tell me, I'm not telling you anything, okay? Suppose I'm writing this. Is this asymptotic or normal comparison? All comparisons are normal, okay? I mean, there is nothing called asymptotic comparison in formal notation, okay? There is no formal notation of like this. I mean, I cannot formally write like this. Okay, formally I cannot write asymptotically that Fn is greater than Gn. Just informally, like I have to do all of this. I have to write in terms of like, okay, for some C, for some n naught. For to avoid all of this, like informally we say that, see, Fn is greater than Gn. Fn is greater than Gn. Fn is greater than Gn, and then I will silent. I will just very slowly I will say asymptotically. Okay, asymptotically. Otherwise, like, I mean, I cannot write it formally. Okay, I mean, like I have maybe I have, I don't know if there is any standard book that uses this kind of notation. I mean, even in the bracket they don't write, I think. I mean, they don't use these comparisons. They will just say that Fn, instead of writing like this, they will just say Fn is greater than, I mean, Fn is bigger than, or something like this, bigger than Gn asymptotically. Okay, they will say something like this. I mean, no one uses this greater or lesser, okay, in asymptotic notations. I mean, this is not a formal notation if you want to do asymptotically. Okay, this is not a formal notation. Whenever someone is saying Fn is greater than Gn, then it means a normal comparison only. Okay, in Qj also, in Qj, I will give some questions where I will be using this notation. And since it is a Qj of asymptotic notations, you will be thinking that, okay, this is asymptotic comparison, but this won't be the asymptotic comparison. So you have to be careful. In Qj, I have used this kind of things 3-4 times in 3-4 questions. Okay, I mean, like in the upcoming quiz that you have, not in this quiz, because this is for the linked list, but in the quiz, I will be using these kind of notations. These are all comparisons are normal. I mean, if you're writing like this greater than is defined for the normal real numbers, okay, not for the functions. I mean, you can define for the function. That's not an issue. I mean, this is for the function only. We are comparing two functions only, but this is not for the asymptotic. For comparing the asymptotic, what you do, you write like this, that Fn or Gn or whatever. If you really want to do is asymptotically, you write like this. There are different notations, right? You write like this. If you really want to do asymptotically, you write like this. Okay. I mean, if you are writing like this in formal settings, then it means this is normal comparison. Okay. In formal settings, if you're writing like this. So in the question, in the quiz or in gate or wherever, if they are saying greater, it means it means normal comparison. Okay. If they have to do it asymptotically, they will use the formal notation. This is the formal notation for the asymptotic, right? This is the formal notation. Okay. Anyway, so here, if I'm talking about this, then tell me, is this comparison asymptotic comparison or the normal comparison? This is very formal definition. Tell me. No, this is a normal comparison, right? This is a normal comparison. This is asymptotic. This is asymptotic. This is asymptotic. These are asymptotic. This is the greater than equal to is normal. Okay. So basically, these are the normal comparisons. I hope that is clear, or it was confusing. See, if I'm saying this, then what does this mean? it means it is normal comparison only. I mean, Tn is less than or equal to C into Gn for some C and after some N naught. Yes, if we are using informally, I'm saying, okay, formally, if you are using this these notations, then only asymptotic. Formally, okay. So, like, I mean, this is basically one informal slide. So that's why always I have to write all comparisons are asymptotic. I mean, if that is asymptotic comparison, informally I will just say it, okay, that this is asymptotic comparison. This is just to I mean, I can say mathematical, what we call it, mathematical convenience. Okay, this is just for our mathematical convenience, I'm saying it. Otherwise, formally, I mean, these comparisons are the normal comparisons only. Okay, if I mean asymptotic, I will write asymptotic. Actually, I wanted to avoid this thing. See, I could have written like this. Okay, instead of writing all of this, I could have written like this. See, what was that? Log of fn, right? Log of gn equal to small o of log of fn, then it means gn is small o of fn. Actually, मुझे मतलब इतना सब कुछ ड्रामा नहीं करना था. मतलब I could have written like this, but instead of writing these formal notations, I've said like, okay, if it is strictly greater, then it is strictly greater and asymptotically. Okay. Otherwise, if I have to write it formally, then what will I do? Instead of writing like this strictly greater, I will say something like this. No, log of gn is equal to this. This is, if this is strictly greater log of fn, then gn is strictly lesser than this. I mean, or fn is strictly greater than this gn, right? I mean, instead of writing all of this, मैंने थोड़ा like just for our naive notation, I have written like this. Okay, I hope that is okay to everyone. Is this okay, everyone? Okay. So I was just avoiding this. Okay. Otherwise, otherwise, I mean, that is fine. So if you are not comfortable, I'm sure you are comfortable with this. But if you're not comfortable with this, then you can write something like this. Okay. Or here you can say log of fn equal to small o of log of gn, something like this, right? Equal to, this implies fn equal to small o of gn or something like this, right? If it is theta, then you can't say anything, right? If it is theta, then you can't say. So basically, like, all comparisons are normal only, unless as until informally I say it is asymptotic comparison. Okay, cool. Now let's talk about this particular question. So tell me this 100 in can it be less than equal to? So what does this mean? 100 equal to order of 0, which means 100 is less than equal to c into 0. For see, there is no n node, I think, right? I mean, there is no this is not a function of n, so that is fine. So for some c, can you satisfy this for some c? These are the normal comparisons only. Can you satisfy this for some c? Actually, again, I'm telling you, in Qs, just be careful, okay? In Qs, you may lose marks if I'm saying Fn is greater than, if I'm using this notation means if I'm using this notation in formal setting, it means the normal comparison only. Okay. In Qs, I won't be using the informal notation that, okay, this is asymptotic comparison or something like that. Okay. I mean, I will be using the formal notation that the gate will be using. So in Qs, if I'm saying this is greater than this, then it doesn't mean that, okay, just tell me in Qs, if I say, in Qs, okay, I mean, in very formal setting, if I say fn is greater than gn, then true or false, just tell me if it is strictly greater. Okay, if it is strictly greater, can fn equal to theta of gn, can this be true? Tell me. This is very formal. Okay, formal settings. Why this is not true? I mean, can we? No, man. This fn could be 2n, this could be n. Aren't they theta? Isn't it strictly greater? Isn't 2n strictly greater than n? Tell me, 2n is strictly greater than n or not? Okay, this question is there in the practice set. Okay, I will just check. So since 2n is strictly greater than n, this is normal comparison, right? This is normal comparison. Then these are the theta also. This is asymptotic. This is asymptotic. This is normal. So in normal comparison, if 2n is greater than n, then why can't be theta? Right? So this is true. I hope you understood the answer. So can it be true? The answer is yes. You can take it 2n, you can take it n. Okay. Now tell me, this 100, can there be any c where 100 is less than equal to c into 0? I don't think, right? Can there be any c greater than 0? Some positive number? So since that is not true, so that's why this is false. What about this? This is 0. Can 0 be less than equal to c into 100? For some c, can you tell me, can you suggest me some c? C equal to anyone? Tell me some number. 1. Yes, 1 will work. Definitely. So this is true. This is true. Okay. So suggest me some number here. 100 is less than or equal to c into 0. Suggest me some c such that this happens. C greater than 0. Okay. C is greater than 0 in the definition. Suggest me some. Okay. Sorry. This is equal. Okay. Sorry. This is equal. This is theta. So this is equal. Tell me. I mean, actually, this is not the very formal definition. I mean, tell me some c where this is less than or equal to this and 100 is greater than or equal to some c2 into 0. Okay. First tell me, I mean, can it be less than or equal to some c1 into 0? I mean, formally you have to write something like this, right? Is this okay to everyone that this 100 equal to theta of 0 means what? You have to say that 100 is less than equal to some c1 into 0 and 100 is greater than equal to some c2 into 0, right? Tell me, is this asymptotic or normal comparison? All comparisons are normal only. Okay, all comparisons are normal. It is just that if I'm using this kind of notation, then only asymptotic. Otherwise, like, see, just to avoid all of this, mathematical jargon, I will just say these comparisons are asymptotic, just to avoid the mathematical jargon. Otherwise, I have to write this complex formula, complex notation and all. Just to avoid these complex notation, I might say that these are the asymptotic comparison. Otherwise, all comparisons, whenever I'm using this greater equal, these symbols, these are normal comparisons only. If I have to do asymptotic, I will be using these formal notations, right? Okay. So here, tell me, can there be a C such that can you make it true? Can you make it true? No, right? Since you cannot make it true, that is why this is false. 0 equal to theta of 100. 0 equal to theta of 100. Tell me, it means 0 is greater than equal to some c1 into 100 and 0 is less than equal to some c2 into 100. Okay. I mean, we can definitely make it true, but let's talk about this. Can you make it true for some c1 greater than 0? Okay. I mean, here it is greater than 0. Can you make it true? No, right? I mean, you can take any c1, it cannot be true. It has to be true for at least one c1. Okay. Okay. So ये समझ में आया ना? I mean, you can take just example कि if that has to be true, then this must be greater than equal to c into 100 and must be less than equal to c into 100, like that, right? Now that is why you will say that this is false. That is why only B is true, right? So none of all of the above, no, B is true, I think. Okay, let me see the answer. B is true. Okay. Do you know, I mean, there is one interesting thing that I can tell you, that here, this big O and these notations here, you say that there exists some constant, right? I mean, there exists some constant for which this is true. है ना, ये big O वाली जो definition है. Is this okay to everyone? Okay. Now Piyush is saying, sir, in the okay. So now just do as a homework, just do one thing. Instead of big O, just take the small o, check out the formal definition, okay, in some book or some online, some good resource, check out the formal definition for the small o. I don't remember if I talked about it, but there is little, I mean, there is little, I can say, twist there. There will be, I mean, here for some seeds, it has to be true, right? For some seed, this has to be true. That's the definition, right? For big O. But for small o, for all C, it has to be true. You can take any C and that will be true. For this is, instead of if there exists, it will be for all C. Okay, that's the very nice thing. I mean, some twist about it. So I'm just telling you, maybe I can ask that in the quiz also. Maybe that will be more clear. Okay. Okay, let's talk about these questions now. Oh, nice. Sir, in the sample quiz questions, equal to strictly greater than small omega, then how this can be used? In the sample quiz questions, matlab sample quiz questions. Okay, I'm not sure what you're talking about. So let's see this. If fn is this, gn is this. If both are equal asymptotically, then because of transitivity, this is equal. Yes, that is true. If fn is less than equal to gn, gn is less than equal to hn, then hn is greater than equal to fn. So they are saying fn is less than equal to gn, gn is less than equal to hn, then hn is greater than equal to fn. Yes, that is true, right? That is also true. If fn is less than equal to gn, gn is less than equal to fn, then they're theta. Okay. So yeah, this is a nice question. Tell me this C. Don't look at the answer. Just tell me this C without looking at the answer. Okay. See, they are theta. They are not equal. This is it's tell me this is the asymptotic or the normal comparison. Normal. Okay. If they're using this equal, normal equal. If they have to use asymptotic, they will be using theta, right? Why will they will be writing normal? So they are saying if this is less than or equal to this, so basically both are related by theta. If both are related by theta, then you can say definitely that fn and gn are related by theta. Does this mean both are really exactly same? So fn could be n, this could be 2n, right? This could be 2n. So that is why this is false. Okay, it is interesting question. That is why this is false. Because see, this comparison is normal comparison. In the quiz also, I will be using these kind of things. So just be careful. Okay, don't just blindly put this is true. Now just see this D. I think theta is possible. So theta is possible. So big omega and big O both are possible. So I think D is correct. So A, B, D are correct, right? This is true. This is true. This is true. So this is false. Okay. So this could be n, this could be n plus 1 as they are saying, or maybe n or 2n, anything. Okay. Is this okay to everyone? See, fn and gn, if you're taking this n, then this is 2n, then yeah, that is fine. I mean, this is big O. This is, if this is 2n, this is n, that is fine. I mean, this constant does not matter in asymptotic comparisons, right? Then they are saying they are really exactly equal. No, they're theta. They're not exactly equal. Okay. Let's talk about this. N power something and log n power anything. I think n power something is always greater. So this will be in the big O. So fn will be in the big O. Okay, this is wrong. And this theta is wrong. Yeah, this is correct, right? So, okay, these are, yeah, that's a nice question. Can you tell me what is the answer for B? What is the answer for B? All of them, right? All of them. because the constant does not matter. These are related by theta. If theta is possible, then this big O and big omega both are possible, right? If theta is possible. Okay, tell me this. This 1000 doesn't matter in asymptotic comparison, so you can just ignore this. This is 2 power n, this is 3 power n. So obviously 3 power n is strictly greater, in fact, right? So this is strictly greater. This theta is not possible. And this is also not possible, right? Okay. This 5 you can ignore. Log 5n, can you ignore this 5? Can you ignore this 5? I think you can ignore, right? You can ignore this 5. Why? Because this n log 5n is nothing but n log of 5 plus log of n. This is nothing but this log of 5. I mean, this is n log 5 plus n log n. And finally, you can say it is n log n only. Okay. Actually, I have went through all of this process. Then only I'm saying that that you can ignore this 5. I mean, by just looking at this, I can't say. I have to just simplify it. Do you remember when can we ignore? Do you remember I told in one of the slide when can we ignore? Whenever you can write the constant something like this, right? C into Fn, then you can ignore this C and this D, right? In those two cases only you can ignore. Okay, this C and this D can be ignored. So if you can't write, see, don't just blindly ignore. Can you ignore this? Tell me. Can you ignore this 2? No, right? I mean, this is not 2. This is 2 power n. How can you ignore 2 power n? This is too much to ignore, isn't it? This is too much to ignore. You can't ignore this 2. Okay, anywhere constant you can't ignore. You have to just see if that can be written as function into multiplication or maybe function plus. Okay, then only you can ignore. Okay. If someone asks you which one is greater, n power n or n upon 2 power n, then obviously n power n is greater, right? Because this is in fact lesser by 2 power n. So you can't just ignore this 2 and you can't just say it is okay. I mean, both are same. No, it's not like that. Okay. Cool. So I think this is n log n, this is n log n. Theta is possible, so all of them is possible, right? It was an easy question, so let's move further. Yeah. If Fn is order of n square, yeah, that's interesting. Tell me. If Fn is order of n square, then Fn and Fn is order of n. Is this true? This is false. Why? Fn could be n log n also, right? N log n. I mean, it is less than equal to n square doesn't mean it is less than equal to n also. Okay. So if Fn is n log n or maybe Fn is n square, then this is false, right? This is false. I mean, this is not always true. Yeah, it can be n square also. Yes, right. Okay. Tell me this 3 power log base is, let's suppose 10. So 3 power log base 10 n and n square. So they are saying if Fn is less than or equal to this, right? What does this mean? This function is same as saying n power log base 10 3. So log base 10 3 is basically, it is definitely less than 2, right? Why? Because log base 10 square is 2. 10 square is 2. I mean, agar yahan pe, if I'm putting 100, then it is 2. If I'm putting 3, then it is definitely less than 2. And if I'm saying Fn is less than or equal to n power something lesser than 2, maybe let's suppose 1.5, okay, then they're saying then it is true that Fn is also less than or equal to n square. If Fn is less than or equal to n power 1.5, then it is also true that Fn is less than or equal to n square. Tell me, can it imply this? Let me know. Yes, right. I mean, if Fn is less than or equal to this, then why not less than or equal to n square? So this is true. Okay, this is true, right? Okay, now tell me this. This is a log n factorial. This is n log n. Can I write big O? Yes, this is what we have seen in the class also, that in fact, in case of log, theta is possible, right? So it means big O is also possible. So this is true. Okay. So you need to put these notations. I mean, whichever is the best notation possible. So this is square root of 2 power n means 2 power n by 2. And this is n into log n power something. Okay. So let's just compare 2 power n by 2 and n. And I'm sure that you can say that 2 power n by 2 is greater. So big omega. N log n and this. So I think this is greater. This is greater, right? Okay. So yeah. So I think, yeah. And what about this? This is n into some function. So obviously this is greater. This is basically what is the difference between these two? This is greater, right? This is greater. This is strictly greater. And this n square and this. So I think n square is strictly greater. So I'm writing big O, but you can write small o also. Okay. Yeah. So here you can even write small omega. Okay. Here you can write small o because all of them were strictly greater or strictly lesser, as we have seen. You can do this question easily, I think. Now let's do this. For any two non-negative functions, fn and gn, both of which tends to infinity, we must have either this or this. I think we have seen this, right? So n power sin n of these kind of functions. So two functions may be incomparable. They are saying either fn is lesser or gn is lesser, but it need not to be true. I mean, they can always oscillate. So maybe fn is this and gn is also this. I mean, they can always up and down. So I think one of the example I have given, apart from the sin n or these things. So fn is n square, but gn is sometimes lesser. At one number it is lesser, then at another number it is greater, right? Gn is a piecewise function like this. So that's why I mean it is not true that fn and gn always related, which means they you can't compare between fn and gn in this case, right? Is this okay to everyone or there is any confusion? Okay, I hope that is fine, right? Now let's see this. If fn is strictly lesser than gn, okay, then it is always the case that fn, yeah, is less than or equal to gn. If it is strictly lesser, then it is less than or equal to also. So here some people get confused, but let me know if that is true. I mean, let me know if you have understood this. See, if I'm saying that x is less than y, then tell me, can I say x less than or equal to y? Is this true? If I'm saying x less than or equal to y, can I say x less than y? Okay. Tell me which of them is true. One is true or not? One is true. Second is not true, right? False. Can you give me the example where second is false? Let's suppose x equal to y equal to anything, 3, right? Suppose something like this. 3 less than or equal to 3. Yes, this is true, but this is false, right? So that's why the whole proposition is false. In case of P implies Q, if this is true, when this is false, I think in only one case, when this is true and this is false, right? Okay. So I hope this is okay to everyone. So here they are saying that fn is less than gn, then fn is less than or equal to gn. Yeah, that is true. And then they are saying if fn is less than or equal to gn, then fn is strictly lesser than gn. That is false, right? Can you tell me the example here? Let's suppose fn is n, gn is also n, right? So this big O is true, but small a is not true. Yes. Let's see this. Fn is strictly lesser than equal to gn, and fn is greater than equal to hn. That is what given. Then fn is lesser than equal to gn into hn. Okay, this is a bigger function. This is a smaller function. Yeah, tell me. See, if okay, we need to check this, right? This fn is less than equal to gn. Is this okay to everyone? I mean, अगर यहाँ पे अगर मैं ऐसे लिख रहा हूँ fn is less than equal to gn, yeah, that is okay because that is even given. Then why not okay, right? That is even given. I mean, if they give you, and if I ask you, can fn be less than equal to gn, which means fn is actually big of gn, then why not? I mean, they have actually given this. Now they're asking this. Now tell me, can you multiply 3 here? I mean, if you multiply 3 here, will this be equal? I mean, will this fn is less than equal to gn? Yes, right? So instead of 3, can I multiply by some function which is an increasing function? ऐसा नहीं है मैं डिवाइड कर रहा हूँ. I won't divide by n or something. Okay, I mean, this is not allowed because all functions are positive and increasing. So if it is an increasing function, so can I multiply with some good number? 100. Can I multiply 100? Yes, I can multiply 100. If I can multiply constant, then why can't I multiply by the increasing function? Okay, hn. I'm multiplying by the increasing function. That is fine. But by chance, if hn is decreasing, then this is not true. I mean, this is sometimes true. Okay, if fn is by chance decreasing, then it is sometimes true. Okay, but if it is increasing, if I see even the constants are good, then why not some good function which is increasing, right? I mean, which will add too much of value to this multiplication, then I can definitely multiply. Okay, so that is why it is always true. Okay, this question is from Washington University. Yeah, so tell me about this. So this means log n power k. Okay, I mean, that's what the one thing that I already mentioned in the first slide, I think. See, this is a shorthand notation for this. Anyway, so this is log n power k, and this is n power alpha. Now they are saying log n power k is never in this. What does this mean? That this I mean, if I'm writing fn equal to big omega, which means it is greater than equal to, right? So they are saying log n power k is never greater than equal to. This is never true. Is never the case. This is they are saying. Tell me, this is true or false? This is true, right? They are saying never the case. I mean, they are negating by themselves. So I think this is true. Okay. I mean, if they are saying it is the case, then it is, I mean, false. They are negating by themselves. They are saying that this is never the case. So I think this is true. Okay. Let's see this. They are saying given two functions f, where f is greater than or equal to log n, and g is less than or equal to n. Now, is this true that gn, okay, is this true that g is lesser than equal to fn? ये n से छोटा है, ये log n से बड़ा है. For each statement, write whether it is true or false. I think this is false, right? Or this is true? They're saying f is no, this is false. I mean, if f is log n, if this is log n and this is n, right? If f is log n and this is n, so I think this is false. So the first statement is false. Is this okay to everyone? See, f is greater than or equal to log n. That's what they are saying. And g is less than or equal to n. Then you have to identify whether this is true or false. So this need not to be true. I mean, you just take f as log n and g as n. Can you write n equal to order of log n? Can you have any constant such that this holds? I don't think, right? So that's why this is false. In fact, C and E are only true. Okay. So this is false. I hope that is fine. Okay. So this is false. Let's see this. Can you write if that's the case? Okay. If that's the case, then can you write f is greater than or equal to gn? Fn is greater than or equal to gn if it is given, right? Is it always the case? Sorry, this G, this G is greater than F is less than or equal to this G. Is it always the case? Can you tell me the example where it is false? See, they are saying F is greater than or equal to log n, right? I mean, it can be anything. It can be anything. F can be anything. Can be n power F can be. So from here, you can say F can be even n power 10, right? N power 5 or n cube, let's suppose. Okay. So from here, F can be actually n cube. And G can be any constant also. Okay. Let's suppose just one or maybe log n. So n cube is not less than or equal to log n, right? For this example, this is false. So that's why this is false, right? Okay. Let's talk about this. This C. In C, they are saying that F of n is greater than or equal to log of Gn. See, you take the maximum of this, you take the maximum of Gn, which is n, then also it is holding, right? You take the maximum of this G and minimum of this F. Minimum of this F, which means to make it false, what you will do? To make it false, you will take the minimum of this, because since this is greater, so you will take the minimum of this. Even if you take it log n, even if you take it maximum of this, then also it is true, right? I mean, you cannot make it false. So yeah, that's a good example. So C is true. You're getting my point? I mean, see, they have given the lower bound on F and upper bound on G, right? I mean, lower bound means minimum it is log n. So you take the minimum log n, you put here, and you put the maximum of n here. Then it is true, right? Okay. Let's talk about this. They are saying Fn equal to Fn equal to. So they are saying this is basically equal. Okay. Let's talk about this fourth one. They are saying this is equal. Can you think about the counter example where these two functions are not equal? Fn is could be n cube, right? Gn could be n. So that's why this is not, I mean, this need not to be theta, right? This need not to be theta. Let's talk about this fifth one. Fn plus Gn. Fn plus Gn. Okay. So Fn is, at least it is log n. Fn plus Gn. So this is at least log n. This is at most n. And then they are saying this is basically greater than or equal to log n. Yeah, that is true. Because this itself is greater than or equal to log n, right? I mean, you are adding something, then why not? Right? This itself is greater than or equal to log n. It itself is at least log n. So that's why this is true. I think that was a good question. So C and E are true, right? Were you able to solve that question? Were you able to solve? Nice. Okay. Now let's talk about this. This question is taken from University of Waterloo. Have you heard about this University of Waterloo? Anyone? Okay. Okay. So this is as far as I know, this is a university in Canada, and this is I mean, very good university. In fact, I have studied from one of the professor of this university. The professor name is Ali Gorji. Ali Gorji. Okay. So no, it is not famous for water. So the professor name is Ali Gorji. This is a machine learning professor. I have seen his lectures on YouTube. like these lectures are just jam. Like I can tell for machine learning, these Ali Gorsi lectures are just jam. Too much good, not just good, too much good. Like he tell everything from very basic, and like amazing intuition he tell for the machine learning algorithms. So only few lectures are there. Yes, only for ML, only few lectures. I think 10 lectures are there, but they are jam. I mean, two good lectures. Okay. So n belongs to this. So what does this mean? I mean, informally we write n equal to this, right? Small omega of 2 power square root of log n. So what does this mean? That n is greater than, strictly greater than, right? 2 power log n power 1 by 2. Can I write? Can I write like this? Tell me. No, right? Okay. So basically it is power 1 by 2, something like this. So we need to compare between these two. Can you compare? Just take the log and I think you can compare, right? So if you take the log, this will be log n. It will be log n power 1 by 2. So this is strictly greater. So that's why this is true, right? Okay. Just take the log and compare these two functions. I think this is easy. Okay. Is there any other way to do it? Actually, I was thinking if we can write this as 2 power log n power something. If we could have written like this, then this will be n. This will be just n. But I think it is not possible. Anyway. Okay. So this is an easy question. I think you can do this, right? Question number 20. Okay, true, false. I mean, you can easily do this. So this is basically 2 into 2 power n. So this is as good as saying 2 power n, and this is as good as saying 2 power n into 2 power n. Okay, so this is the difference. So in fact, this is strictly greater. So that's why this is false. This is true. In fact, theta is possible here, right? The difference between these two is that this is 2 power n into 2 power n. This is 2 power n into 2. So into 2 is just, you can just ignore that. Yeah, that was extremely good question. Anyone was able to solve it? Okay. So let's see this question. Assume that the function f and g such that fn is order of gn. Decide whether you think it is true or false. So 2 power fn is, so they are saying that fn is order of gn, which means fn is less than or equal to gn. Then if you make it 2 power fn is also less than or equal to 2 power gn. Is this true? I mean, given this, can you imply this? Just think about it. No, you can't take log and check. The reason being is that here the equal to is involved. Okay. If you look at the log toolbox, if you look at this log toolbox here, I in fact separate it out. Okay. I mean, there is no equal to here. If it is strictly greater, then only strictly greater, strictly lesser, then only strictly lesser. Okay. I mean, if it is, I will take the log and I will tell you, don't worry. But first see the slide. If it is strictly greater, then only strictly greater. Let's suppose after taking the log, you are getting strictly greater than equal to. Then what can you comment? Can you comment anything? See, apart from this, apart from these three conditions, I mean, you can also say that after taking the log, if you are getting strictly greater than equal to log of gn, then also can't comment. Okay. If equal to is involved, then also can't comment. Okay. So basically, let me take log. That's not an issue, but I just revised that slide. Okay. So let's suppose you want to compare between these two functions, 2 power fn and 2 power gn. Okay. Versus this. Then what you will do? Take the log. it will be Fn, it will be Gn. After taking log, I mean, this is after taking log, right? After log. After taking the log, you are getting both functions such that this is less than equal to, I mean, this is given to you. It is given that Fn is less than equal to Gn. I mean, it is given to you. So after taking the log, you got some relation which is less than equal to, right? I mean, it is given to you. Then what can you say about the original functions? You can't comment, okay? So see, in the log, you have to be careful about this equality. In the log, if you are getting, in fact, less than equal to, greater than equal to, I mean, until and unless you are getting strictly less or strictly greater, then you can't comment. So basically, log is not helping you here. Okay. So, I mean, the question is that this is less than equal to, I mean, this is given to you. Then can you say 2 power or 2 power also less than equal to? This is the question. Let's take some example. Let's take this Fn to be 2n. Let's suppose this is n. Tell me, given condition is true or not? Given condition is true or not? What about the derived condition? 2 power 2, 2 power 2n and 2 power n. Just see this. 2 power 2n and 2 power n. 2 power 2n is 2 power n into 2 power n. Too much, right? It is too much. You're getting my point? So if I just ask you to compare between 2 power n and 2 power 2n, then you will say 2 power 2 power n and 2 power 2n. Yeah. Then you will say 2 power 2n is too much. So since 2 power 2n is too much, you will say that after 2 power, after, see, earlier it was true, but after 2 power, this 2 power 2n, you are getting 2 power 2n, and here you are getting 2 power n. Here you are getting 2 power n. So after 2 power, this is, I mean, this is not holding, right? After 2 power, this is not holding. Okay. So that is why you will say earlier it was true, but after 2 power, it is not holding. So this is false. This was the one of the trickiest question I can say in this practice set. No, just check this. This Fn is 2n and Gn is n. Is this true? This is asymptotic comparison. I mean, all comparisons. I mean, here this is asymptotic. I'm talking about asymptotic sense. Okay, because the given is asymptotic. So whenever I mean, in this particular lecture, whenever I mean, this basically, I can say from the context you can understand I'm talking asymptotically or normally. So most of the time I will be talking asymptotically, okay, because it is given asymptotically. Fn and order of Gn. So asymptotic. This is asymptotically given. So I'm taking Fn as 2n. This is n. Now you do 2 power 2n. This is 2 power 2n. This is 2 power n. Can you write this as asymptotically this? Can there be a constant that satisfy this? Can there be a constant that can make over this? Can there be a constant that can compensate this relation? I don't think there is a constant, right? Whatever constant you take, I can always have. I mean, this is 2 power n. This is a function. Whatever constant you take, since that is just a constant, however bigger you take, I will take that n such that will be greater or lesser than that constant. I mean, you can't compare to this constant and function. Function is always greater than any constant. Okay, any increasing function, any increasing function is always greater than any constant, right? Okay. So here, that is why you will say this is false. This was one of the trickiest question I can say. Just a second. Okay. So see, they have also taken the same example. However, we saw the last week that 2 power n. Last week means last slide. Okay. So I have put the questions order in such a way that you first get this. So we have seen in the last slide, you can see. Right? Last slide means this. This is false. Although these are from different universities. Okay. These are from different universities. Now let's talk about this. Let's talk about this. Assume that now the question is same. Okay, they are saying that Fn is asymptotically lesser than equal to Gn. That's what they are saying. And now you have to compare between log of Fn. Then can you say log of Fn is also asymptotically lesser than equal to log of Gn? Actually, whenever it is exponent, now, whenever it is exponent, see, in case of exponent, you have to be very careful about the constant. So constant, now, whenever it is in the power, it is in the power of exponent, okay, then it is too much. So in case of exponent, you have to be careful about these constants. Constants say like the story will change in case of exponent, okay. But in case of log, these constants doesn't matter actually, because log of any c into n is just log of c plus log of n. Actually, in case of log, this constant doesn't matter. In case of this exponent, constant matters. Okay, I mean this may change the whole story. Okay. How it is false? Let's take it n square. You are saying take it n square, take it 2 power n. After log, this is n. This is, sorry, this is log n. This is n. Yeah, that's true. I mean, for this particular case, this is true. I mean, in fact, we compare n square 2 power n like the log, right? No, don't take decreasing function and all. Just take increasing functions only, because time complexity, space complexity is always increasing function. So in the algorithm, we will talk about the increasing functions. It's log of Fn, not Gn. Okay, this is a typing mistake. I think this is a typing mistake from their end only. Maybe. Okay. So this is a typing mistake. This is. Anyway, I hope you understood. Okay. Actually, this is true. This is true. Okay. So see, in case of log, actually, see, earlier what was happening, the constant were playing a crucial role, right? This constant 2 were playing a crucial role, because after the exponent, this 2 is not just 2. This 2 is 2 power n, right? I mean, this 2 is not just 2. It was 2 power n into 2 power n. So basically here, in case of exponent, constant plays a crucial role. That's why this is the counter example here. But in case of log, constant won't matter. And like we have seen in the class also, that if some function is greater, right? If some function is greater, then after taking log, it cannot be lesser, first of all, right? It must be greater only. So if it is, see, if it is greater, if it is, see, if Gn is greater before log, then after log, it is greater. But if it is equal, then after log, it cannot be lesser. If it is equal, if Fn, actually, okay, in case of, yeah, asymptotically, it cannot be lesser. Yes. So after log, because log is an increasing function, right? And constant won't matter here. So basically, after log, actually, the formal proof is very complicated. That's why I'm avoiding it. Okay. I mean, there is a formal proof, and that was too complicated. Even for me, it was complicated. So for you also, it will be complicated. So that's why I'm avoiding it. So just check with the counter example. So for this case, just understand like this, that here in case of exponent, the constant will play a crucial role. That's why we were able to come up with the counter example using this, using the play of this constant, right? Using the play of this constant. But here in case of log, the constant won't play any role. Why? Because log of Cn, I mean, if even if you have the constant, this is log of C plus log of n. I mean, the constant doesn't play any role. So whatever is the earlier relation, after log also the same relation hold. I mean, after, because the constant won't play any role. I'm not saying in the reverse way. Okay. I'm not saying, just look at this carefully. I'm not saying this. Okay. There is a difference. I'm not saying this because from here to here, this is, you are taking 2 power. I mean, how to go from here to here? How to go from here to here? You are making it 2 power, right? I mean, you are making it 2 power. Then only you're getting this, right? I mean, if you are make it 2 power this log fn, then only you're getting fn. So I'm not going. Okay. So see, I'm not going from, just a second. Yeah. So I'm not going from this log to this fn. I'm not going in the reverse direction. I'm saying that if fn is less than or equal to gn, I mean, whatever is the earlier relation, after the log also relationship hold. Okay. After the log also relationship hold. I'm not saying that if asymptotically, I'm saying, okay, asymptotically, which means if it is the, if this is the case, then after log also this is the case. This is true. But reverse is not true. Okay. Which means you can say fn equal to order of gn, then whatever is the relationship, not just order. Okay. Any notation here. Any notation in the sense, like, I mean, just the big notations only. You cannot have a small notation. So that's why, I mean, either you write big O or theta or the big omega. So anyway, let me just take the big O only. So after the log also relationship hold. But if you are having this, then this is not true. This is not true. Okay. I mean, from here to here, you're making 2 power. From here to here, you're making 2 power. From here to here, you're taking log. So anyway, you can what can I say about all of this story is that like I cannot tell you the proof here because the proof is very complicated. Even it was complicated for me, so that's why I'm skipping it. So you can just understand like this: if you're taking the log, then constant won't matter. So it is not possible to come up with the counter example here. Earlier we were able to come up with the counter example. Reason being was that here the constant is playing a great role. Okay, here the constant were playing a great role. So I hope a little bit it is making sense to everyone that why we are not able to come up with the counter example here, because the constants are not playing any role here. Okay. So always, okay, also always remember that this toolbox is always true. I mean, there is nothing wrong with this toolbox. Okay, you compare after the log, and this all of these things are working perfectly. Okay, it is greater than also greater and all. But if it is greater than equal to after the log, you can't say anything. Okay, cool. Now let's talk about this question. If both are equal, then fn power gn. Can you give me the counter example here? Both are equal, almost equal, right? Then here also they are equal. So these are the normal questions. Now tell me the counter example. Okay, 2n and n. Let me just check. 2n and n. This will be 2n power n. This will be n power 2n. Yeah, I think that should work. Or both are not equal, right? Because this is 2 power n. This is 2 power n into n power n, right? This is n power n square. N power n into n power n, right? N power n square, or maybe n power n into n power n. So basically, if you divide by n power n, then it is 2 power n and it is n power n. So definitely it is strictly greater, right? Because it is n power n. It is strictly greater. In fact, 3 power n is strictly greater. Why not n power n? 3 power n, 4 power n is strictly greater. So n power n is strictly greater. So this is not theta. Okay, you can just play with the constants. If this is exponent, you can just see what kind of constant are working to make it false. Okay, just see how the constants are arranged. So I think here it is false. This claim is false. Okay, you just take 2n here and n here. Let's check this. This is saying that fn is less than or equal to gn. This is saying hn is greater than or equal to gn. Sorry, I have written it wrongly. Sorry about it. Fn is greater than or equal to gn, and hn is less than or equal to gn. तो fn upon hn, gn से कुछ बड़ा, gn से छोटा. It is true or false? Then it is always greater than or equal to 1. Yeah, I think this is true. Hn, it is greater than or equal to 1. So basically, fn is greater than or equal to hn, right? Fn is greater than or equal to gn. Yeah, and gn is greater than or equal to hn. So fn is greater than or equal to hn. Yeah, because of transitivity, it is true. Because of the transitivity, you can say fn is greater than or equal to hn. Yes. So this is true. Okay, why? Because see, fn is greater than or equal to gn. Okay, it is given, and gn is also greater than or equal to hn. This is also given. So anyway, from here you can say definitely that fn is greater than or equal to hn, right? Which means fn upon hn is greater than or equal to 1. Okay, so that's why this is true. Let's see this. This is from Corman. I hope spelling is correct. No, spelling is not correct. This is from Corman. Like, tell me if this is true or false. I mean, that is here also in this university, but yeah. So this is saying strictly lesser than gn, right? I mean, the function whatever you are writing, it is strictly lesser than gn, or something is strictly the function whatever you are writing is strictly greater than gn. Can there be any intersection of that? So I think this is true. There cannot be any intersection, right? So that's why this is true. Okay, let's see this. I think this is a good question. Let me check what is the time currently. Do you want to continue this tomorrow? We can, I think, continue this tomorrow, right? These are the 40 questions. So I think 15 questions are left. So you just try those 15 questions and then we can continue tomorrow. Okay, cool. Yeah. Thank you, everyone. Okay, take care. Bye-bye. Thank you. Just try those remaining questions, and I hope these concepts will be very much clear to everyone. Okay, thank you. Take care.